Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode, I'm joined by Adam Wenchel, Vice President of AI and Data Innovation at Capital One, to discuss how machine learning and AI are being integrated into their day-to-day practices and how those advances benefit the customer. In our conversation, we look into a few of the many applications of AI at the bank, including fraud detection, fighting money laundering, customer service, and automating back-office processes. Adam describes some of the challenges of applying machine learning in financial services and how Capital One maintains consistent portfolio management practices across the organization. We also discuss how the bank is organized to scale their machine learning efforts and the steps they've taken to overcome the talent shortage in the industry. A big thanks to our friends at Capital One for their sponsorship of this show. As you hear in this conversation with Adam, Capital One is hosting their second annual Data Intelligence Conference, which will bring together machine learning practitioners and researchers for several days of presentations and talks. The conference will take place later on this summer. I'm really looking forward to it, so I'll keep you posted. A quick thanks to everyone who joined us for the first session of our TWiML Fast AI study group this past weekend. We had a great discussion, and I'm excited to get the group rolling. This first session was just an orientation, so there's still time to join in if you missed it. Keep an eye out for the recap video going up this week via the Slack group. You'll find more information at twimlai.com/fastai. Finally, our next TWiML online meetup is taking place next week on Tuesday, June 12th. Kelvin Ross will be presenting the paper Cardiologist-Level Arrhythmia Detection with Convolutional Neural Networks, which is work by researchers in Andrew Ng's lab at Stanford. For more information, visit twimlai.com/meetup. All right, let's do it. All right, everyone, I am on the line with Adam Wenchel. Adam is Vice President of AI and Data Innovation at Capital One. Adam, welcome to This Week in Machine Learning and AI.
Thank you, Sam. Appreciate you having me on.
Absolutely. Why don't we get started by having you tell us a little bit about your background and how you got involved in AI?
Absolutely. So I, studied computer science as an undergrad at the University of Maryland and took the only two AI courses that were available at the time, which is actually still the case at many undergraduate curriculums. And when I graduated in the late 90s, I actually went to work. One of my professors had gone to DARPA to start a new program there. And so I was able to, I immediately went to DARPA and was working in AI research there for the first couple of years of my career. So have been involved in this field for quite a while. It's funny to look around now and see all the, how many jobs there are in this industry. At the time, it felt like a very small community and was seen as somewhat quixotic at the time. So this current, massive surge in interest has been fascinating to watch. And from there, I went into a series of startups after working in DARPA for a couple of years, some of which involved a little bit of AI, but a lot of them were straight, web application startups. And then about 5 or 6 years ago, maybe a few more than that, I started, with the kind of confluence of these really enabling technologies like GPU and big data and cloud computing that have kind of led to the recent resurgence of machine learning coming together, really started to get back into it in a big way, in particular in the cybersecurity domain, and which is really ripe for machine learning. And so for the last six or so years, I've been really focused on machine learning. And then joined Capital One about 2.5 years ago, initially to lead up a big project they had to create a new data platform and machine learning suite of machine learning analytics for cybersecurity. And that has since kind of my scope here has kind of expanded, and now I help with machine learning implementations all across the company.
Oh, fantastic. Well, maybe we can have you give us a lay of the land, an overview of the different ways ML and AI are being used at Capital One.
Absolutely. So in the financial world, there's really kind of no end to the way machine learning can be deployed. There are
a lot of possible use cases, huh?
Absolutely. I mean, it's just a fundamentally quantitative field. And so everything from, the way we fight fraud, and there's many different flavors of fraud, to financial crimes like money laundering, to to the way we service our customers, making sure that they have the best experience as possible and can get answers to the questions they need as quickly as possible, whether they're talking to a human or a bot or on their mobile app or the web app. We use it all over the place, as well as for, a lot of our internal back office processes, which for any large scale company, bringing automation to that can create huge efficiencies.
What would you say is an example of one of the more innovative projects that you're working on there?
I think a lot of the way we're taking on fraud, both transaction fraud as well as account takeover fraud and identity theft, have been really innovative. Similarly, the work we're doing in money laundering has really begun to bear some fruits recently.
Can you walk us through one of those examples? I'm curious about some of the data sources that come into play. What your the way you approach modeling there, and other areas related to those topics that might help us understand the way you go about applying ML and AI in your environment.
Yeah, absolutely. So one of the ones that we like to talk about is an application we have called Second Look. And Second Look is for it's something that helps our customers out very directly. And it's I know that I'm sure all the listeners to your podcast are very dutiful about checking their credit card bill every day and making sure that all the transactions look correctly. But for those of us who are perhaps a little bit less diligent about it, what we've done is we've actually trained a machine learning system to go and spot transactions that that we should highlight to our attention, because everyone's busy. And so, you don't always have time to review your bill. And so it's good to know that someone's kind of checking it for you, if you will. And so that can be things like spotting, say, a suspiciously high tip on a restaurant bill, or getting double charged for the same service or product, or just having sort of a recurring payment that 1 month all of a sudden significantly higher than usual. There's a number of reasons why, things that you might want to kind of be notified about on your credit card statement. And, obviously there's a real kind of precision that's needed, because if you alert on too many things, then it just becomes a frustrating user experience. But we also want to make sure that that stuff doesn't slip through the cracks either. And so we've put quite a lot of work, and it's really one of the kind of innovative ways that we're improving our customer experience. And it's funny, like when I meet people at a party or something and tell them I work at Capital One, by far and away, this is the thing that people mention the most consistently is how much they love this feature, and they always have a story about some charge it caught that they wouldn't have caught otherwise that was incorrect that they've been able to straighten out. So I think that's a great example of the way machine learning is bringing some transformation into the financial services industry.
Oh, that sounds like a feature I'd like to have. I imagine that the training data for something like this comes from your traditional customer reported issues.
Yeah, so we do have, there's a number of ways we look at it. We do have sort of a customer feedback loop in there where they can kind of tag stuff as being problematic, or if alert, not being problematic. I think with those kind of systems where you have kind of human generated tagging, they are one source of ground truth. They're not you don't want to over rely on that kind of stuff, but it can be very helpful. I think there's also a lot of work from our data scientists looking at things like using sort of unsupervised learning and anomaly detection kind of approaches to kind of tease out some of the patterns in the data, and that's another way that through things like label propagation we can begin to really hone in on the transactions that we want to alert off of.
Oh, interesting. And you mentioned that you came into Capital One with a focus on cybersecurity. I imagine that that's a big deployment area as well.
It is, yeah. There's with cybersecurity, you just have such massive amounts of data, and even with a large team of analysts who staff our cybersecurity operations center, they're really constrained to only be able to look at a really small amount of the number of events that we have on our network and our computers every day. And so, machine learning really gives a great opportunity to, number one, cut through all that noise and really kind of surface the events that are most that we really want to have the analyst focus on, that may be suspicious, that or maybe they're completely benign, but we need to have someone to check into, and then we kind of get smarter along the process. And so that can be anything from a piece of malware on a computer to some sort of attempted data exfiltration. There's a lot of different attack vectors, malicious emails, whether that's phishing or spear phishing or extortion attempts, or there's just quite a lot of threats that any large company faces, and particularly one that manages a great deal of money.
Now, in a situation like cybersecurity, where Capital One certainly is far from alone in having to worry about these kinds of concerns, do you find that your primary vector for kind of inserting machine learning into solving some of these problems is via off-the-shelf software, meaning your vendors kind of built ML and AI into their products, or are you kind of out in front of it with your own data scientists building kind of custom systems to help you stay ahead of your cyber adversaries?
Yeah, it's a very good question. I think for us, we do buy a lot of kind of best of breed cybersecurity products, and I think it would be it's certainly advantageous. It's really important to take advantage of kind of the rich product ecosphere that's out there. There are, when you kind of deploy a lot of these solutions, there are still opportunities that present themselves that are either unique to Capital One, or just that are created by the way that the product marketplace landscape lines up to kind of even strengthen things beyond that. And that's we focus on those opportunities.
Are there any examples in that domain you can give us, at least at the high level?
Sure. One of the ones that we've talked about at a couple conferences recently is on detecting malware callouts, and specifically malware callouts that use DGAs, domain generating algorithms. We've done some pretty innovative work there that we've presented on at conferences, and we'll potentially be sharing in the future. But that's it's been a fun challenge where we've applied some of our really interesting machine learning approaches using convolutional neural networks and other features to bring kind of this problem has been around for a while, and it's kind of one that a number of AI researchers have taken on, and we have a pretty novel approach which has been working well for us.
So what's a malware call out?
So you can imagine if you're, if I'm sure it would be you, but if one of your friends' computers got infected because they clicked on the wrong link, or double clicked on the wrong attachment in their email, and then had a piece of malware on their computer, it might, once your machine's infected, the next stage is for it to reach out to a server controlled by the attacker and say, hey, I managed to infect this computer. What would you like me to do? And that can be anything from lock their computer till they pay us a ransom in cryptocurrency, to search the computer for any files containing with the title financial disclosures or something like that, and download those to the malicious server. I mean, there's a wide variety of things you can do once the computer's infected. A lot of times it's participation in a botnet where you're maybe trying to hack into a system controlled by another company through some sort of brute force method. And so when it makes that call out to the server, we focus on kind of detecting at that point. That's one of the areas that we've explored. And the way that those call outs are made, the way that those servers are effectively the domain names they use, some of the attackers have come up with some really complex algorithms for basing the host names on either some sort of time-based algorithm where, maybe there's like 20,000 different domain names per given day. And you can say at any given time, there could be one that you decide to register that your malware will call out to, which makes, the traditional kind of blacklist, whitelist approaches to blocking malware callouts very difficult. And so we've focused, that's one of the categories of attacks that we've focused on.
And you mentioned that part of the solution here involves the use of convolutional neural nets. CNNs are typically used in like image recognition types of tasks. How have you applied them to the cybersecurity use case?
Yeah, so CNNs are famous certainly for kind of computer vision tasks, but more recently there's been quite a lot of work. I think a real kind of surge of interest in using them for more NLP-based tasks. And that's this kind of category of problem that I'm describing fits into that NLP category.
Can you elaborate on that a little bit more?
Sure. So, really what we're trying to do is distinguish between a host name that maybe is, let's say, phonetically plausible, but not a real word, like Google, to one that is just a string of jumbled up letters. That's kind of the first step. And then, some of the more recent attacks actually use are dictionary-based attacks where they'll generate the domain name from real dictionary words, but just put them in odd combinations. So understanding like what's an odd combination and what's not. Is Facebook an odd combination, or does that make sense? And it really kind of gets into a decent amount of kind of language understanding to really to create a model that can accurately distinguish between those types of domain names.
It sounds a bit like the challenge that Google and others face keeping up with spammers as spammers learn how to use proper grammar.
Very, very much so. And it's it's continually whether it's spamming or cybersecurity, it's a constant cat and mouse game, right? So it keeps it fun. It never gets boring.
And so one of the challenges that the industry has been faced with is the talent shortage. How have you managed at the bank to address that?
Yeah, it's a good question. There is a massive talent shortage going on right now, and there's no silver bullets to that answer to that question, but there's a number of ways we're addressing it. So obviously we are hiring, going aggressively after recruiting people who have good amounts of experience in that field. There are not a lot of those people, but we're certainly very work very hard to make sure that we can attract as many as possible. We also have a program at Capital One called the TDP, the Technology Development Professional, where we go out to primarily the top 20 computer science departments in the nation and recruit heavily from that. And once they're here, they work all over in a bunch of different technology areas. But the ones that come to the Center for Machine Learning, we actually have a pretty rigorous process around training them and getting them up to speed on machine learning. And so we're kind of famous for being the group that gives homework, and we do things like we have weekly paper sessions where we'll review kind of academic papers and sort of discuss their merits. And I think that's one of the things that really distinguishes the machine learning from other kind of software engineering, computer science disciplines is it still has a very academic bent to it. So even though there's like massive applicability across a wide range of business problems, there's still kind of a culture of making sure that you're keeping up with the latest in academic literature, and the academic literature is produced by probably just as much by commercial teams as it is by academic teams, and so it really creates a unique culture. So that's making sure that you're continuing to do ongoing training and that you're able to take people into the group and train additional machine learning talent that way is immensely important to being able to meet the talent needs that we have.
It sounds like you're going after the same students that Google and a Facebook might go after. Do you find that you're challenged to convince them to join a bank as opposed to one of these more sexy kind of internet-born social media type of plays?
Yeah, it's a good question. We definitely do compete head to head with a lot of the tech companies for talent, and and that is a challenge. It's fortunately getting easier as more and more people become aware of really what a tech company Capital One has become. But the way I look at it is at Capital One, I think that we've seen disruption happen via machine learning across a wide range of industries, right? Whether we're talking logistics with self-driving cars or healthcare or commerce. And I really think that financial services is you're seeing the beginnings of a similar kind of disruption. And so I think there are a lot of people who are really excited about not just taking on marketing and advertising, but actually being able to apply their machine learning skill to something really impactful, like how do people manage their money and how can we empower people more to take better control of their financial lives and really kind of set them up for lifelong financial success.
You mentioned Capital One kind of becoming a more and more like a tech company. And I think we kind of throw around in the industry that, all companies are going to need to look more and more like software companies over time, sooner rather than later, in fact. But Capital One actually has a pretty long history at this. I remember Capital One was featured in a book that I read many years ago, Competing on Analytics by Thomas Davenport, I think is the name of the author, but really talked about how the company was, before machine learning became cool like it is now, really applying predictive analytics and other things to the way it, made decisions, to the way the company made decisions. So my question is, in the company, do you find that having that history is kind of predispose your business counterparts to kind of understand and be ready and willing to work with machine learning and predictive and statistical kinds of approaches and algorithms? Or do you still find yourself, with many of the cultural challenges that some of your counterparts in companies that don't have that history might have?
Yeah, it's a great question, and I think that's really good context about Capital One. It's something that I didn't fully appreciate when I first started talking to them about joining, but have really come to appreciate now, which is that the DNA of the company is very much in that data analytics space, and that's how they, that was their whole initial kind of founding hypothesis. And Capital One is still founder-led, and so Rich Fairbank, who's the CEO, who started the company with that conviction, still runs the company with that conviction, and it really trickles down. I think where machine learning is obviously a pretty different shift from kind of some of the traditional stats and quants that have been done in a lot of companies for many years. And it requires sort of a slightly different way of thinking about problems. And so I think that, yes, there's a long, it's squarely in the company's DNA to think about, to think in a data-driven way, and data-driven insights are worth their weight in gold. I think we have had to evolve, like a lot of people, along, more machine learning lines, and that's something that we're embracing. But the DNA of the company is definitely there. And it's been amazing to watch how much the company has embraced that.
Are there specific aspects that you can point to or examples you can give as to the way that cultural shift is manifesting at Capital One? What are the things that you're finding your business counterparts kind of needing to hear the most, and how are you helping them come to terms with those things?
Yeah, I think there are a number of changes, and I think everyone's everyone's really excited and enthusiastic about it. And so there's been, what I've seen, people have really taken it upon themselves to kind of go out and educate themselves on what machine learning can accomplish, and kind of separating the hype from the reality. I think one example is of kind of the evolution that's needed is, traditionally, I think at a lot of large companies, data science and software and systems engineering were sort of distinct activities, and a lot of the really disruptive machine learning systems that you're seeing being built at in any industry are really kind of being produced when you have that software engineering, data engineering, and the kind of data science all working together as one whole. So if you talk about like a reinforcement learning system or any sort of interactive system, machine learning system, it's critical that it's not just a standalone model, but as part of a system. And so I think that's been a big, it's been kind of an evolution for us to really make sure we're building teams and setting up projects in that way to take advantage. But that fundamental belief that data-driven insights or data analytics can really power great gains has always been in the company's DNA.
One of the big themes that came out in an event that I recently held, AI Summit, was that often companies, particularly large companies, get caught up in comparing traditional software engineering with data science and data science driven efforts. And the particular area that was mentioned was just this notion of the key word in data science being science, and it's a much more exploratory type of process, and doesn't lend itself to agile, for example, in the way that traditional software development does. Is that your experience there as well? And how How have you been kind of working to, what are your methodologies there, and how have you been working to kind of fuse software engineering and data science and the other, you mentioned data engineering as well, into a process that kind of works well for Capital One?
Yeah, it's a good question. There's a couple big themes wrapped up in that. The first one is you're talking about the science and data science, and a lot of times it has been essentially humans kind of experimenting with the data, looking for insights, right? Like trying to find, in search of an insight, and then finding that insight, and then turning it into some sort of model that gets that can be put into production and make predictions. With machine learning systems, what we're really trying to do is create a system that sort of continually generates these insights in an automated way, and that's a pretty big shift from sort of a human looking for insights for themselves to building a system that can kind of continually look for insights and generate them. And so it does require a slightly different skill set and a slightly different way of thinking. And then in terms of the methodology, Agile is great for software development. I think a lot of modeling is much less deterministic. Like if you're trying to achieve a certain degree of accuracy on a model or efficacy on a model, it's really tough to predict and plan out, how quickly you'll get there and what you might have theories, but it's just not that deterministic about when you're going to achieve the kind of results that you need to make a model really valuable. And so, the process, I think that people end up adopting is a little bit different than the traditional kind of Agile methodology, because you have to take a really exploratory approach to it, because you're not sure, what each step. Whenever you take a step forward, you're gonna learn sort of on the fly what the next avenues of exploration are going to be, and you need to be prepared to react with that.
Right. Yeah, one of the interesting slides that came out of this session was that, whereas you can kind of think of traditional engineering and Agile as being more linear, right? We have these burn down charts and we're kind of creating linear value over time. With machine learning, it's more of an S curve because of that exploration up front. And this is, kind of in mapping out ROI. That ROI takes longer to kind of get to and requires some critical mass. But then when you do, you're able to get a significant ROI in your efforts relative to, again, traditional development. Do you see that kind of relationship between ROI and machine learning as well?
I definitely agree that there's a lot of times a longer upfront period of exploration. We've seen on certain projects some pretty dramatic ROI on these projects, like just because if you're coming into a system or a business area that hasn't, essentially right now with machine learning, because it hasn't been applied broadly, there's a lot of kind of greenfield opportunities and
kind of low-hanging fruit.
Yeah, a lot of low-hanging fruit, but stuff that can be really impactful, and so some of the ROI on some of these initial on projects can be pretty dramatic. I think that the hard part is just scaling up the talent so that you can implement systems in all the opportunity areas that you have.
And so given a constrained base of talent, how do you approach portfolio management across the business? Do you, I've talked to some folks that kind of take, all their talent and apply it to, their most pressing problems, kind of like a moonshot approach, with the idea that, if they solve or make a dent in that, they'll have a huge impact. Other folks, go for kind of quick wins to help establish, a machine learning way of thinking within the organization. How do you balance that?
Yeah, I think that's right on the mark for us. We started this Center for Machine Learning about a year and a half ago. And I think initially when we were getting started and we were sort of building some organizational muscle, we took on a fairly broad kind of organic set of projects that really allowed us to help the business partners understand what machine learning can do. It helped us develop a little muscle around delivery. And that's how we got started. But, once we've been doing that for a while, we sort of said, all right, we need to take a step back and actually sort of take a top-down assessment of the enterprise and understand where are the really high leverage opportunities for machine learning. And so it's obviously a conversation that we had with our business partners who have a lot more context around, their business areas. And we really work together to help understand and prioritize what those areas are. And we've devoted, probably the lion's share of our resources against those really transformative opportunities. That said, we still do hold back a team, our internal consulting team, that's available for sort of like the broader ones that may not be the moonshots, but that are really important. So we want to make sure we're servicing both, and we have the right balance there between going after these really transformative opportunities, but also not ignoring like the hundreds of efficiency gains that collectively can be really add up to something pretty powerful.
How are you organized around data science? It sounds like you've got a center, so there's some centralization there, but what's the relationship between that Center for Machine Learning and the various business units?
So, we have a center of excellence, but it's the machine learning expertise is, across the company, and the data science community is there's, data science is spread all across the company. So I certainly don't want to give the impression that it's all centralized, because that's not the case.
Fair enough.
I think having the center of excellence has allowed us to have a small core that really work closely together to sort of help define best practices and really, it's nice when you have a tight cluster of people, because the amount of knowledge share and shared learnings is tremendous, and it really kind of accelerates the growth professionally of that group. But we are, we have people who rotate out from that center and go into the lines of business and help kind of seed teams that way. And so there's a number of ways that we kind of manage that balance. And so machine learning is really like all the business teams have embedded data science groups in them as well that are really doing great things with machine learning. And so the Center of Excellence is kind of one of the mechanisms we have towards building out machine learning systems at Capital One.
So for an enterprise, in financial services or elsewhere, that recognizes the importance of machine learning, and is somewhere on the spectrum, but doesn't yet have a center of excellence of some sort. Is that something that you recommend? And if so, what do you think, what groundwork has to be in place before one can do that?
I do think it's something I recommend. I think that one of the reasons why we've been able to attract a very high level, degree of talent in a very, very competitive talent segment is that working in the Center of Excellence is very it's a very compelling opportunity for a machine learning professional. And so, from that perspective, I think it's been enormously helpful. So I think that as to what the groundwork you need to lay is essentially, you need to have a strong core of people, an initial core, and because that's what's going to attract, the additional talent. And so that's for us a big part of the reason why we initially created the center was to create that really kind of attractive place for talented machine learning professionals to come work at.
When you look out across your industry, what unique challenges do you see to applying machine learning within the financial services context?
I think the big challenges are just, it's a heavily regulated environment, right? And so it's one of the reasons we are focusing or investing heavily in areas like explainability and fairness, because there's obviously many years of regulation and working with the regulators to understand best practices for managing models and making sure that you're managing the risk and that's generated from those models appropriately. And so I think that's it's a really kind of unique to financial services practices around that and understanding how to navigate that. It's tough. I think one of the reasons why I think we've seen less disruption from startups in the financial services industry is because of those type of challenges. And it really takes, a larger bank that has all the teams and the personnel and the experience of having dealt with, those type of regulatory processes for many years to be able to push more aggressively into deploying machine learning in some of these heavily regulated areas.
So on the one hand, financial services has had to deal with a lot of these issues before, but at the same time, machine learning is changing things. What are some of the things that are changing in the way a bank would have to think about or deal with the issues that you've mentioned, ethics, fairness, transparency, those kinds of things?
Yeah, so I think that we could talk for hours just about this subject alone. But I think with a lot of these models, they're effectively they're more complex than the models that have been traditionally used, and with that complexity comes additional power. But there also makes it a little bit harder to really kind of fully understand everything that the model is doing, and so having to invest in kind of automated ways of bringing that level of transparency it has been a big focus for us. And so, I think that's a pretty big shift. And then working with the regulators to make sure that these new ways of kind of understanding the models are sufficient and kind of meet the spirit of the regulation. And it's not just working with the regulators. We're also working with kind of academic partners and others to really understand collectively as a group, like what the best way is to bring that same level of understanding that we've had from traditional quantitative models to machine learning. And that's, it's very much a work in progress, but it's also a process that we're very committed to and putting quite a lot of effort into.
You mentioned in there automation. Can you talk about some of the ways that you've approached automation around explainability?
Sure. Well, I think a lot of it is there's a number of papers that have been written, and we've done our own internal work around if you have this extremely complex model, how do you get it to kind of explain its actions when it makes a prediction and why it made the prediction? Mm-hmm. And so having some sort of automatic system that can, it's not something these models are so complex, you're not going to manually trace through it and understand the decision logic. Right. But there are sort of a growing set of techniques for dealing with this in an automated way that, the systems will actually generate explanations for you that do a pretty good job of talking about the major reasons why a particular prediction was made.
So are these techniques like the Lime paper, or like fitting more transparent, more explainable models to more opaque models, or did you have some other things in mind?
Those are certainly two big areas. Yeah, the Lime paper is a very seminal one, and it's probably the best known in this field. And I think that there's just a tremendous amount of interest in this topic, and so there's a lot more work, newer work that's coming out as well on this topic, and so I think it's an exciting area to be in. And I've been at a couple major ML conferences recently, and this has been a huge topic for people at them. And so I'm really excited by what I see in terms of the progress that's being made in getting to a point where we do have that, a good degree of explainability from these really complex models.
What's kind of the lay of the land in terms of the spectrum of model complexity that you're using there? Like, is it? I guess I'm pausing because I'm guessing that I know the answer. That it's like a 80% relatively simple things, and then you've got some more complex stuff. But like, how? I guess maybe the question is more. You mentioned using CNNs. Like, how much are you using CNNs? How much are you using deep learning? And you mentioned reinforcement learning. Like, do you have reinforcement learning based apps in production? I'd like to get a sense for the range of complexity of the things you're doing.
Yeah. So, a lot of the stuff we're doing is, so for starters, anytime you have a system where you're bringing machine learning to it for the first time, a lot of times you can get a big benefit just comes from kind of the basic data engineering and
sure.
and kind of getting the system straightened out and even applying a relatively simple non-deep learning type model to it can it gives you massive gains.
Right. And there's that's another reason for the pause, right? There's nothing wrong with like taking the simplest approach and spreading it far and wide, right? You can get a lot of benefit in doing that.
Yes. And those simpler models are really good about like telling you feature importance and things like that. And so that's really good when you're in your initial stages to make sure there's not like some weird quirk in the data that's causing some results in the lab that will never be reproducible in production data. And there's a number of reasons to start simple. But all that said, like we know that, deep learning like CNNs is really like there's a reason there's a lot of excitement around that type of stuff. And then techniques like reinforcement learning, where you really kind of give the systems a little more autonomy to explore the space are just fascinating when you can kind of when you have a problem that's appropriate for it. And so we are doing a lot of research or a lot of work on deep learning based models, CNNs for computer vision and NLP type applications, and LSTMs for a lot of like time series based type prediction and things like that. And so there's a lot of excitement about what those techniques can do. I think that, as I mentioned, the center is relatively new, so a lot of those uses are not yet in production, but certainly we're driving in that direction, and excited to see what that yields over the next couple of years.
I'm curious, are there any applications of how far have you gotten with reinforcement learning? Have you identified some potential applications within Capital One?
Yeah, so I'm not going to go too much into specifics, but there are a couple that we're eyeing. It's not right for every situation, and one of the things about the financial world is, for many of the problems, you may not know whether a prediction was successful for 3 or 4 years, right? And so doing reinforcement learning when your feedback cycle is that long creates its own set of challenges, and so it's something that that we definitely focus on, because we do think it's a really powerful technique. But you need to make sure you have the right problem to focus it on and are doing it in the right way.
I imagine that the bank has come across that kind of issue, these attribution problems in lots of different areas, trying to attribute, the success of marketing campaigns and other things. To what degree do you have you identified, or do you think that a path forward is in bringing some of the techniques that you've learned in that traditional space and applying it to RL, or is that more the domain of research and you'll wait till it gets figured out?
What's interesting is, as you mentioned earlier in the podcast, Capital One has a lot of history in analytics space, and in particular testing, which we're talking about here. The more I've kind of learned, and as we've kind of gone into, explored more business areas for applying machine learning, it's really interesting to see. I think in the early days that was something Capital One's like always been very good at, is really having kind of control groups and test groups and really being disciplined about that. And so I think there's a lot of practices that we're able to kind of leverage that were existing in Capital One for that type of testing.
Okay, so maybe shifting gears a little bit, your group is sponsoring an event at Capital One coming up soon, the Data Intelligence Conference. Can you talk a little bit about the objectives for that conference?
Yeah, absolutely. So we're really excited about that. We held the first one. Last year was the first one we did. It's called the Data Intelligence Conference. It's held in McLean, Virginia in June. And I think our website is data-intelligence.ai. And what this is it's really kind of intended to be a hybrid between an academic conference and a practitioner-focused conference, really kind of blending the best of both worlds. And we really saw a need in that space with that focus. We had a great lineup of speakers last time. We're going to have the lineup of speakers this time is shaping up to be even better. We have separate tracks on the couple key tracks on one on fairness and explainability AI, another one on data and ML visualization that I think are going to be quite good. And so it's just an opportunity to really kind of convene a group to get together, and lots of great conversations happen. It's a very kind of collegial feeling conference. It's held, being in the DC area, there really isn't a major machine learning conference in the Mid-Atlantic. And so it's really kind of filled a nice gap and attracted a pretty big crowd for us. We sold out last year, and we've increased the capacity significantly this year, but I'm still expecting it to sell out well in advance.
Any particular session you're really looking forward to this year?
I think we're still kind of finalizing the list, so I don't want to make him a favorite quite yet, at the risk of alienating anyone. But there'll be some good ones. Who's
the target audience for it?
So I think it's really focused on practitioners. Although we do have a lot of students, grad students, and we have poster sessions and things like that. So there is an academic bent to it, but really it's for machine learning practitioners.
in financial services in particular, or more broadly?
More broadly, yeah, I would say I wouldn't say it's primarily focused on financial services. There obviously is some content that are using examples from financial services industry, but it's a full spectrum machine learning conference.
Awesome. Well, from what I've seen, it looks like a great event. Any kind of parting thoughts or additional perspective that you'd like to share with our audience before we close out?
No, just, I think that we're at a very interesting time. As I mentioned at the beginning of the podcast, having been in machine learning for the better part of, if not continuously, but it's starting 20 years ago, it's just amazing to see. And I think that, there's a lot of kind of important questions like we were talking about around fairness and explainability and ethics in AI that are critical to think about, along with all the exciting technological aspects. And so I think the next few years should be very interesting for us, and we're excited to be a part of it.
Fantastic. Well, Adam, thank you so much for taking the time to chat with us.
Great. Thank you.
All right, everyone. That's our show for today. For more information on Adam or any of the topics covered in this episode, head over to twimlai.com/talk/147. Thanks once again to Adam and Capital One for their sponsorship of this episode. And thank you so much for listening, and catch you next time.